Okay, we're going to use properties to justify steps in solving equations. We have two examples here, example A and example B, where a problem is worked out and each step is justified by a property. Now, the first step is always a given. It's just the problem that was given to us. Some of these are filled in already for you because they're not necessarily properties you've talked about, but we will get to them eventually. So when I'm looking at justifying properties, I like to look at just two things at a time. I like to say, if I need to know what goes here, I'm only looking at what's on that line and directly above it and seeing what's different. So between these two things, the only thing that changed, let's see, what is it? It looks like the grouping of x plus 3 plus negative 3 changed. X plus 3 was grouped, and now it's 3 plus negative 3. Change of grouping is the associative property. This is the associative property of addition. So now that I know that, I'm going to pretend I'm going to move this one down and have the rest blocked off. I'm not going to look at anything except these two lines. These two lines of the problem. I've got x plus the quantity 3 plus negative 3 equals negative 5 plus negative 3. I've got x plus 0 equals negative 5 plus negative 3. The one change is 3 plus negative 3 became 0. 3 plus negative 3 becoming 0 is the inverse property of addition. Oops. So again, I'm sliding down to just focus on two lines at a time. I'm looking for a difference between x plus 0 equals negative 5 plus negative 3 and x equals negative 5 plus negative 3. X plus 0 is equal to x. That's the identity property of addition. Oops. Here, let's see, sorry. The part that is missing, well, there's nothing missing anymore. I think that means we're done. Let's see. I get rid of this. This problem is done. We have the properties. Sometimes it's overwhelming to look at it all at once, so it kind of helps to block off parts as you go. In this second example, I'm going to pause as we go to see if you can guess what comes next. Okay. Comparing these two steps will get me what goes on this line. The difference between these two steps, 3 times the quantity x plus negative 6 equals negative 21, and 3x plus 3 times negative 6 equals negative 21, that would be the distributive property. From here to here, it's saying 3 times negative 6 is negative 18. That's why that was written there. If you look from this line to this line, the addition property of equality, two sides stay equal if you add the same number to each side, is something we'll talk about soon, but not yet. What changed from the quantity 3x plus negative 18 plus 18 to 3 plus the quantity negative 18 plus 18? This is again the associative property of addition. Okay. As we keep going down, we have to look at the difference here. 3x plus the quantity negative 18 plus 18 gets us 3x plus 0. That's a plus sign, a little hard to see there. 3x plus 0. What property is that? The inverse property of addition. I keep moving down. The change from 3x plus 0 to 3x, the 0 went away. That property is called the identity property. Of addition. Identity stays the same. This problem is taking a lot longer to work out on this left side than it probably should. From here to here, the change was negative 21 plus 18 became negative 3. That's just the sum, negative 21 and 18. From here to here, the multiplication property of equality says if you multiply both sides of an equation by the same number, it stays equal. That's fine. But from here to here, 1/3 times 3x, still the same. 1/3 times negative 3 became negative 1. That is the inverse property of multiplication. We finally have a multiplication property. As we keep going, 1/3 times 3x became 1/3 times 3 times x. What's that? The associative property of multiplication. Keep double checking. Let's see. 1/3 times 3x became 1x. That's the inverse property of multiplication. And I can get the final property looking at these two things. 1 times x becomes x, and that is the identity property of multiplication. As a whole, these problems look a little intimidating, but if you take it one step at a time, they're really not so bad.